at the end of this video, I'm going to give you a trick on how you can calculate this without going through all of this long route. So let's continue. Now, we've seen that we have our non-bonding pair, we have our bonding pair, right? I would say that our non-bonding pair is what we know as our lone pair. So I'm just going to clean this and come back to this. We've seen how these pairs are formed by knowing our valence electron and knowing how to fit them in here. But you know that the reason why electrons are or elements are involved in combination is because they want to find stability, right? So it means that whenever we have something like this, it has involved in a combination, we can see that that compound is now stable. Now, what you have here is 1, 2, 2 electrons are here, right? 2 electrons are here. So this oxygen has 4 bonding, 4 electrons, of course, 2 bond pairs. Now, it's important to know that this oxygen, the reason why it was said it is stable is because oxygen actually has attained 8 electrons. So if 2 or if 4 are involved in bonding, meaning that the other 4 are not involved in bonding. Come over here for carbon. This is 2, 4, 6, 8. So carbon here has 8 electrons. It is stable. Now come over here. This is 2, 4. Oxygen, of course, again, would not have to fit in the other 2 here. And these 2, they are not involved in any bonding. So how you're going to know the lone pair for your CO2 is that we count this. This is 1 lone pair, 2 lone pair, 3 lone pair, 4 lone pair. So why CO2 has 4 bonding pair of electron, this same CO2 has it has 4 lone pair too. 4 lone pair of electron. So it has 4 lone pair of electron. So why this has 4 bonding pair of electron, your CO2 has 4 lone pair of electron. Hope you're following it, right? So the next thing we want to see is your nitrogen gas. Alright, so let's see your nitrogen gas, okay? Now, your nitrogen gas, this is nitrogen. This is nitrogen. What is the atomic number of nitrogen? The atomic number of nitrogen is equal to 7. Meaning that your K shell, we have 2. Your L shell, we have 5. Right? So like I said, when we were trying to form our bond for CO2, I said that this N has 5 valence electrons. How many does it need to attain stability? And like I would always reiterate, don't forget that your N shell needs at least or needs a maximum of 8 electrons for it to attain stability. So L needs 8, N needs 8, N needs 8. This nitrogen falls on L shell and the valence electron on that L shell is 5, but we need 8. So what is going to make this to be 8? 3 more electrons. I'm going to put that 3 electron here. Same with this nitrogen. It has 5 valence electron. What's going to make it 8? 3 electron. And I'm going to put that electron here. So here we now see that this nitrogen now has 1, 2, 3, 4, 5, 6. This nitrogen now has 1, 2, 3, 4, 5, 6. Remember in your covalent combination, whatever belongs to this or belongs to this, or whatever element, whatever electron found in between elements belongs to the both elements. So because these electrons are in between nitrogen, all of this thing between here belongs to this guy. All of this between here belongs to this guy. So we're going to bring now these 2 electrons would form a bond. These 2 will form a bond. These 2 will form a bond. But now remember that this has 6 electrons now. This has 6 electrons now. This is not complete. This is not complete. So meaning that there are 2 electrons here that are not involved in bonding. And for this one, there are also 2 electrons that is not involved in bonding. So now we have our nitrogen 2, 4, 6, 7, 8. For this we have 2, 4, 6, 7, 8. Now your nitrogen molecule, which is N2, would have three bonding pair of electron, three bonding pair, and for the lone pair, one lone pair, two lone pair. It's going to have two lone pair. Did you get this? All right. Let's look at the second one, oxygen. Now, oxygen gas, oxygen molecule or gas. We have oxygen here, oxygen here. What is the atomic number of oxygen? Atomic number of oxygen is 8. So it means that your K shell is going to have 2. Your L shell will have 6. How many does this need to be complete? 2 electrons. So I'm going to put the 2 here. Of course, this is the same element, so it's also going to need 2. Now, how many electrons does this oxygen now have? 1, 2, 3, 4. How many does this now have? It has 1, 2, 3, 4. Now, because this has 4, it means there are 4 electrons that are unaccounted for. So this is going to form a bond. This is going to form a bond. This 2 has 1, 2, 3, 4. Means that there are 4 electrons that are unaccounted for. So the bonding pair here in oxygen is 2 bonding pair. The lone pair here, oxygen gas, has 4 lone pair. I hope you got that. Now, if you notice, this is now similar with what you have here. Okay. How many lone pair this has? We have 4 lone pair and 2 bonding pair. You will not call this one bonding pair because it has 2 bonds together. No. Now, what do people who use AI overview to go and use that same AI and check how many bonding pair does your oxygen molecule have? Right? What will you get? Do that quickly, and I want to see your answer in the comment section. Now, this has 2 bonding pair. Hope you get that, right? It has 2 bonding pair. We cannot say this has 1 bonding pair. No. The bonding pair does not mean this as a bond. The bonding pair means the pair of electrons involved in bonding. Yeah, there are exceptions to this, of course, but not this. Now, the next one we're about to look at, for these your compounds like ammonia, BCl3, water, and hydrogen peroxide, we want to look at how we can find their bonding pair and their lone pair. Now, okay, wait. So I've done this before with you guys, so I'm just going to change this to PCl5. Now, these two have exception when looking for your bonding pair and your lone pair. Why these two we can also find the lone pair and the bonding pair of these two using the same method. It doesn't apply to these two, and of course, it doesn't apply to these two. So I'm gonna not. So why these two has a different way of looking for their bonding pair and their lone pair, these two can also use the same method. All right, so now, okay, back to this. Now for your PCl5 and your BCl3, I want to tell you something about the exception that when we are looking for our lone pair. When you're, okay, let's do this way. If the valence electron of your central atom equals to the number of elements that central atom is interacting with, they would cancel out. And when they cancel out, that particular compound will have 0 lone pair. Let me explain. Phosphorus has atomic number 15. Your K shell, we have 2. Your L shell, we have 10. Your M shell, we have 5. 10, 10, 12, no. 2, sorry. Okay, sorry, this is PCl3. Okay, yeah, PCl5. So your K shell will have 2, your L shell will have 8, and your M shell will have 5. PCl5. So the valence electron for your PCl5 for phosphorus here is 5. This phosphorus is reacting with 5 atoms of chlorine. So 5 phosphorus is also reacting with 5 atoms of chlorine. They would cancel out, and your lone pair for this is going to be 0. But if you want to calculate the bonding pair, you can still use the method that we have been using. How? This method, of course, that says that, okay, let me clean this. Of course, this method that says that since this has 5, it's going to be reacting, be the middle guy. So it has chlorine here, chlorine here, chlorine here, chlorine here. Let's say, let's put one chlorine here, and chlorine here. 1, 2, 3, 4. 1, 2, 3, 4, 5. Now, where will I start filling my electrons? This needs 3 electrons to be complete. This needs 1. So I'm going to start from the one needing lesser electrons to fill in this. So I have 1, 2, 1, 2, 3, 1, 2, 3, 4, 5 chlorine. Let me remove one. 1, 2, 3, 4, 5 chlorine. Right? So phosphorus is reacting with 5 chlorine atoms. So this chlorine has 17 atomic number, 287. So it needs 1 to be stable. I'm going to put that one here. This needs 1, I'm going to put that one there. This needs 1, I'm going to put that one there. This needs 1, I'm going to put that one here. This needs 1, so I'm going to put that one here. This needs this needs 5 to be stable. This has 5 valence electron and also needs 5 to be stable. So I'm going to share that 5 between this atoms. So I'm going to put one here, put one here, put one here, put one here, and I'll put one here. So this now has how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This now has how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. So this is going to form a bond, 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 this is going to form a bond. 1, 2, 3, 4, 5 bond. So your PCl5 has bonding electron of 5, lone pair of electron of 0. Hope you understand that, right?